Chapter 7 Computational Thinking. Computational Thinking. Computational thinking is defined as the process of identifying a clear, defined, step-by-step solution to a problem. It is an approach that uses logical and critical thinking. This technique of problem solving is used in our daily lives, not only in computer science, but also in language, history, science, math, and art. Computational thinking is useful for computer programmers as it helps them develop efficient computer programs or software. Importance of computational thinking. Computational thinking helps in breaking down a complex problem into parts and develop solutions for it. It is useful in handling simple tasks like solving puzzles to handling difficult tasks like developing software. Some of the features of computational thinking are: it teaches us how to solve complex problems, it strengthens our comprehension skills, it helps in developing the critical thinking skills, it develops logical and analytical skills, it helps in designing efficient software systems. Components of computational thinking. There are 4 key components in computational thinking: decomposition, pattern recognition, abstraction, algorithm. Decomposition. Decomposition is an important part of computational thinking as it involves breaking down a problem into a series of small, more manageable parts. This makes complex problems easier to solve. For example, to build shelves for a storage space, we practice decomposition by creating a blueprint or plan to determine the size of shelves and the materials we need to accomplish the task. Pattern recognition. Pattern recognition involves finding similarities, connections, and observing patterns or trends. The purpose of pattern recognition is to further simplify the problem of finding where details may be similar or different, as well as building a continued understanding of the more complex problem. For example, 47, 58, 71, 86, 103. Here, the difference of second and first number is 58 minus 47 equal to 11. Now let us find the difference between other consecutive numbers in series. 47 plus 11, 58 plus 13, 71 plus 15, 86 plus 17, 103 plus 19 equal to 103 plus 19 equal to 122. Abstraction. Abstraction involves focusing on the important points relevant to the problem and ignoring the irrelevant details. For example, making coffee with a coffee machine. You need to know how to use a coffee machine to make a coffee without thinking about the internal working of a coffee machine. Algorithm. Algorithm involves developing a list of steps that can be followed to complete a task. An algorithm is a set of guidelines that describes how to perform a task. Think of an algorithm as step-by-step instructions that create a predictable pattern in lines of code. Algorithms are used in everyday life as well as in the field of computer programming. A well-written algorithm is the first step towards developing a good program. Let us consider a few examples of writing an algorithm. Problem 1. To polish your shoes. Algorithm. Step 1. Open the shoe polish. Step 2. Put shoe polish on brush. Step 3. Polish the shoe. Step 4. Again put shoe polish on brush. Step 5. Polish the other shoe. Step 6. Close the shoe polish. Problem 2. To go for a class picnic. Algorithm. Step 1. Decide the picnic venue, date and time. Step 2. Decide the picnic activities. Step 3. Go to the picnic venue on the decided date. Step 4. Do the activities planned for the picnic. Step 5. Come back to the school. Wrap up. Computational thinking is defined as the process of identifying a clear, defined, step-by-step solution to a problem. Decomposition involves breaking down a problem into a series of small, more manageable problems. Pattern recognition involves finding similarities, connections, and observing patterns. Abstraction involves focusing on the important points relevant to the problem and ignoring the irrelevant details. Algorithm involves developing a list of steps that can be followed to complete